viewers, welcome back to another video. In this video I'm gonna show you how to make a Pacman game using C++ and open frameworks. So well, it is not a Pacman game, it is very similar to the Pacman game and I call it as Pacman. So let me just show you how the game will look like. So for that we need to open that up. So here we this is the GUI of the game, and this is the horizontal and vertical grids. These are obstacles shown in black, these are apples, this is the avatar shown in yellow, this is the start point which is shown in green, end point shown in green, and the status bar, right? So the avatar will move via arrow keys on the keyboard, right? And the objective is that the avatar should pick 10 number of apples, right? The target is 10, so the avatar should pick 10 number of apples in the specified time and go to this endpoint, right? For example, if the avatar has 8 number of apples and it is at here in less than 10 seconds, then the user will lose the game. And again, for example, if the avatar has 10 number of apples in less than 10 seconds and it is at here, then the user will win the game. So right, very simple. So now let me just show you the class diagram as well. So here it is. So this is the class diagram. Let me just zoom it a little bit so you can see it more clearly. So this is the class diagram. This is the off-app class, which is the default class of open frameworks, right? And for those of you who doesn't know about open frameworks, just comment me down below, so I will upload more videos, more beginner tutorials in the upcoming videos. Just comment me down below and I will do that. So this is the GUI class, our custom class. The setup grid function will set up the grids, draw grid function will draw the grid, update function will update the grid, set status bar will set the status bar, you know, where the status bar will be drawn, how it is positioned. So everything is taken care of by this function. Find t's and draw t's. So this is very interesting, right? So find t's, as you can see, we have total 6 number of obstacles. It's constant. We have total 6 number of obstacles, and every time you start the game, the obstacle position, apple position, and the start and end points, everything will be drawn at random position. So you never know when you start the game, you never know where will be the obstacle, where will be the apple, where will be the start points. So this is making the game more interesting and difficult to play, right? So there are 6 number of obstacles, and from 6 there are 2 t obstacles, right? This 2 t obstacles. From 6 we have 2 t obstacles, and remaining 2 will be single obstacles. They could be horizontal or vertical depending upon the position and type of t, right? As you can see it here, that this t has been rotated by 180 degrees and this t has been rotated by 90 degrees, right? So their position and their type will determine the remaining 2 obstacles, but there will be 6 obstacles. That is constant, right? So this is why we have find t's and draw t's. Find obstacle will find the remaining 2 obstacles. Either they will be, you know, horizontal or vertical depending on the position of the t obstacles, right? Find apples, draw apples, delete apple at, right? So this is very interesting as well. When the avatar is at this position, this box at the apple position, when the avatar is at apple position, that means we have to take this apple, that means we have to delete this apple at this position. So for that we have this, you know, function draw delete apple at. For that we need to give this function the avatar position, which is start point and end point. Okay, so find start and end points. We are going to find the start point and end point. Again, I told you that their position will be random. Okay, and we are going drawing them: draw start point, draw end point, draw score, draw target score. get box width and height. So this is very interesting. The box width, every box is of same width and height, so this is making the game more symmetrical, right? So every box width and height is same, right? Get AV pos X and AV pos Y. This is the position X and Y of the avatar in pixels, right? In pixels, not with respect to boxes but with respect to pixels, right? So this is it. And again, there is one more class that is not a class but it is simply a constant declaration of constants. Total apples is 6. Again, depending upon the difficulty levels, we have difficulty levels as well, 3 difficulty levels. So in the first difficulty level there will be total 6 number of obstacles, and end time will be 10 seconds, right? This is shown in milliseconds. This is the target scored in first difficulty level. Number of boxes remains constant, which is 10. Width of obstacle is 9.0. This is the width of obstacle, right? And required obstacles, again, total number of obstacles is 6, so required obstacles is 6, right? So now let me just show you the class. So this is the GUI header file, and we have the struct box position. For box position we have X position and Y position, and for every boxes we have its width, its height, and its position, and its position is again X and Y, right? Again, we have obstacle position as well, which is its top left corner. Again, we have to show you that for every obstacle we need to find the top left corner, which is here, the top left corner, which is here, here. So for every obstacle we have to find the top left corner. If we have this top left corner, we can draw the obstacle, right? So this is why we have this top left X and Y, and we have obstacle map, right? So we're going to save these obstacle positions in a map, in an array, so we can use them later to draw them, right? So for that we have this struct, and these 4 functions are used to set up the grids. This functions I will just explain it later. This is the step size, this is xmin, xmax. Total number of boxes is 10, that's why it is 10. Total number of vertical boxes is 10, that's why it is 10. X grid n means x grid number of samples, and x grid step is the distance between 2 x grid lines, right? As you can see, this is the first x grid line, second, third, fourth. So the distance between 2 x grid lines will be 1, so this is 1. Again, y grid line is again 1, so this is again making the game symmetrical. And this is pixels. In pixels, these are the arrays that we have used. These are, scores and bound obstacles. Box width and height, every box width and height is same. These 3 variables are used for this time, and these are the struct variables. Box is equal to the size of this array is 10 because number of boxes is 10. So again, obstacles are 6, apples are depending upon the difficulty levels, okay, and the start and end point. These are open frameworks add-on variables, right? So we have used this font here, so for that we are going to use this of 2 type font add-on. Add-on are simply libraries, you can call it libraries, but in open frameworks they are called add-ons, right? So 2 type font is for fonts. GUI, for GUI we have OVX panel. For line we have off polyline, and line is used for drawing the obstacles. And images, we have used various images. So this is the image, this is the image, we are loading them from the directory. So for that we need to have this add-on, which is of image. Now let me just show you the GUI class as well. So these are the function. I will explain these 4 functions later, this function as well, but let me just show you the setup grid function. So this is the default function of open frameworks. We are loading the font, we are loading the image, Apple image, we are getting the number of samples, we are giving the number of boxes, the step size, and we are getting the number of samples, right? And we are also saving the number of samples in X variable, right? So every X X is an array, and X array we have every sample that is step size away from each other, right? And of get width and height is again we are getting the width and height of this whole GUI, and we are saving it in pixel maximum and y pixel maximum, right? And X grid n means that X grid number of samples, right? So we're giving X pixel, X min, X max, X grid step size, and we are saving it in X grid, right? And we are getting X grid number of samples, and we need them X grid n to convert this X grid that we have get from here, to convert this X grid into pixels, right? So map vect is simply converting it into pixels, so that is why we have used map vec. Similarly, y grid is doing the same. Box width and height, any two successive position will give you the the box width and height. So this is very self-explanatory. And again we have this for loop here, we are saving box width and height in each of the boxes, right? And in each of the boxes we are saving the pixels as well, right? In each of the boxes. For example, if I say here box 2.pos.x, that means second box X position in pixels, right? Second box X position in pixel, that means this box position X in pixels, right? So that is why we are saving it in this array, right? And again we are finding T obstacle, finding obstacles, printing them, finding start point, finding apples, and these functions are very self-explanatory. Draw get function is very very important. This is the elapsed time, this is very self-explanatory. Set status bar will set the status bar of background color. The background color of the game is white, as you can see it here, so we are setting it up here. And enable grid, we are drawing the grid here, right? We are drawing the grid here, and as you can see it here, as grid n is used here to draw the grid that we have get in the setup grid function that I just explained it to you. And now we are drawing the obstacles, start and endpoints, and apples. Update function is empty, so doesn't matter. Find T's. Okay, so this is very important. Since I told you that there are total 6 number of obstacles, right? So the first T obstacle will be constant, whose position will be constant. It will be like this, rotated by 180 degrees, and it is constant, but its position will be random. It could be here, it could be here, it could be here, it could be anywhere on the grid, but it will be of this type. It is always rotated 180 degrees, right? So the first T obstacle position will determine the second T and the remaining obstacles. So the first T obstacle position is important to determine the remaining obstacles, right? So let me just show you here. We are getting the off random add-on. We are using this off random add-on to determine the top left corners of the first T, and we are saving these positions in the obstacle map. And now since we have get this first obstacle, we can get this obstacle as the second obstacle as well from this first obstacle. Again, you just see how it works. Since the top left corner of this first obstacle is 1 3. Why it is 1 3? Because it is one box away from here, one box away, one is X, and 3 box away, that means 1 is here, 3 is here. that means top left corner is 1 comma 3. So we can get this obstacle from the first obstacle, right? 1 minus 1 is 0, that means second obstacle x position is 0, and this every obstacle ends at 2 covers 2 boxes. Every obstacle covers 2 boxes, right? So when it is 3, it will always end at plus 2 position. 3 plus 2 is 5. So the x position is 0. We can get the y position as well. How? We know that it ends at 5, that means the second obstacle y position is 5. So that's how we are drawing the first t obstacle, right? So that is why this function is doing the same, right? So first t is done. Now generating the second t. The second t is generated from the position of the first t. The first t position is important in determining the second t, right? So if the first t is in this 3 boxes, right? If the x position of the first t is in this 3 boxes, then the second t will be rotated 90 degrees and it will be 3 boxes away from the first t. 3 boxes away from the first t, right? If the 7 and 9, that means if the first t is 7, 8, 9, if the second t is in this boxes, is in this 3 boxes, then the second t will be rotated by 90 degrees and it will be again 3 boxes away from the first t. So this is done here. Is hor obst is true and is hor obst true. That means if the first t is vertical and second t is horizontal, that means that the remaining obstacle will be horizontal. As you can see it here, the first t is vertical, the second t is horizontal. That's why the remaining 2 obstacles are horizontal. That is why we are setting it true here, right? Again, else case. In else case, if the first t is not in the 3 boxes, neither in this 7, 8, 9 boxes, then it's obvious that it will be in the middle of the grid. So whenever this is the case, then the 2t will be upside down. The 2t's will be upside down. Let me just show you how this is actually working everything. So now it's running. It's loading the libraries and everything. So in a few moments it will be set up and running. So we just have to wait. So now as you can see, again we have vertical and horizontal t. We have to run it again until we find the condition when 2 t's are upside down. Yeah, as you can see here, the 2 t's are upside down and they are in the middle of the GUI. And when this is the case, the remaining 2 obstacles will be vertical, right? So that is why I said is where obstacle is true, right? And this is getting the second t here, and the calculation, you can see they are very similar, and the draw t's will actually draw them, and off draw line will require 2 points, right? 2 points. For drawing the obstacle, we should get this point and this point, right? So if first we are drawing first t, we need to get this point and this point. So again, since this is the vertical obstacle, that means x position is not going to change, y position is going to change. Since here it is 3, here it is 5. Okay, so box x position first, box y position second, box 0 position again second point, x position is again the first position of the first point, and the second y position will be plus 2, and again we check if it is less than 10. If it is not less than 10, that means the y position is outside the grid and we doesn't want that. That's why we are dealing with that here. And This is the first T. We are drawing them here, and you can take a look at here that how the remaining T's are actually drawn. And find obstacles again. If is obstacle, if it is true, that means the two T's are vertical and horizontal. If that is the case, then the remaining two obstacles will be horizontal, and those positions are calculated here, and you can check them. They're very self-explanatory. Draw obstacles, will actually draw them. Rotate vertical, rotate obstacle is again very self-explanatory. This is very important. And start x is equal to 0, y is equal to 0. That means that we are we have 4 different set of start and end points, and this from this 4 different set of end points, there could be anytime you start the game, there could be different set of start and end points. For example, start x is equal to 0, y is equal to 0 simply means that the start point is here, 0 0. X is 0, y is 0. Similarly, I start x is equal to 9, y is equal to 0. That means x is equal to 9 is here, y is equal to 0 is here. That means start point will be here. Similarly, in the third set, x is equal to 9, y is equal to 9. That means x is 9 here and y is again 9 here. The start point is here, and this condition in this run, this condition is true. So this is how we actually just find the start and end points, and we actually draw them as well. So you can check them, they are very similar. Find apples, this is very self-explanatory, you can check them. Draw apples, delete apple, they are very self-explanatory. Of app class, again of app class, these 3 functions are default functions of open frameworks. Set avatar start, that means we have to set the avatar start position, and for that we have this function. Update AV frame, update AV frame is used to update the AV avatar frames. Avatar is animated, as you can see here, that the avatar is opening and closing its mouth. For that animation we are using this function update AV frame, right? Similarly, we have draw avatar, move AV left, right, up and down, apple, take apple, and key pressed. Whenever the key is pressed, whenever any key on the keyboard is pressed, this function is called automatically, right? So let me just show you how things are working here. So in the setup function, we are going to call the setup grid function of the myGUI, and again myGUI is again the GUI class object, right? And image, we are loading the emoji GIF, which is the avatar. Here again we are enabling the sound, and avatar position x and y, again the starting position x and y will be the same as the start point and end point. So we are getting the start point and end point positions from the GUI, and we are setting this position to avatar position x, and the avatar the background color is again white, and we are setting the avatar start positions. Update AV frame is going to open and closing mouth thing is working here. This function is called automatically, and it is going to call every time. It's going to call call, it's going to call repeatedly, right? So draw function is same, it's going to call repeatedly, and this 3-4 lines is used for animation of the avatar. This is for drawing the avatar, and these things here is going to check whether we have won the game or lost the game. So for that we need to check if the specified time has been met, if the avatar is at end point, and if the score is target score, and if the elapsed time is the end time. If that is the case, we show the dialog that game is over and you won, right? And the remaining conditions are very self-explanatory. So AV frame is very self-explanatory. Draw avatar is very self-explanatory. Now I'll just show you the AV write function. Okay, so the update dot function, update dot variable, whenever it is 0, that means avatar is facing right. So here, as you can see, avatar is facing left, right. So if update dot is 0, that means avatar is facing right. If it is 90, that means it is facing down. Similarly, you can check them. So first of all, we check the current rotation of the avatar. If it is at left, that means update dot will be 180, right. Update dot will be 180. For left, it is 180. So when it is 180 and we need to rotate it to the right side, for right side we have to we have 0 degree rotation. So 180 minus 180 is 0. If 0 means right, 0 means right. So that's why we are rotating it to right. And this other conditions are very self-explanatory. And the rotation is allowed, but the movement is not allowed in some cases, right. Remember, when the avatar is at this position and it is facing left, and you need to go from this box to this box, and this obstacle is here, then this movement is not allowed, right. So you need to change your route, right. So for that, we need to restrict the movement whenever there is an obstacle next to the avatar, right. So in that case, we are calculating this here. If the match is found, if avatar is next to obstacle, then the movement is not allowed. If it is not, if no match is found, that means avatar position X is changed, right, by 1. We are incrementing it by 1, so we move it to the next box, right. Same is true, if we are getting the apple, we can take the apple and move AV left, right, up and down is very similar. If you understand the AV right function, you can understand the remaining functions. Key press function is called automatically whenever the key on the keyboard is pressed. So whenever the key is on the keyboard is pressed, we need to compare it. If it is the up key, whenever it is the up key, we need to move the avatar up, move AV up. If it is the down key, we move the AV down, and similarly the remaining functions. So now let me just run this function, this program once again, and let's just play the game. So now I need to go to endpoint and take I lose the game, right. Why? Because the target was 6 and I scored 6, and 15 seconds, in 15 seconds I was not in the endpoint, so I lose the game, right. So this is it. I hope you like the video. Please don't forget to hit the like button and the subscribe button to see more interesting videos in the upcoming session. Have a nice day.